My dear students, good morning and good afternoon. So after a long time I am able to interact with you in this live session. Today, that is, I'll be explaining about how to actually formulate the acrylic emulsion paint, and not only that, that is what are the ingredients and how to test those individual components also. So I'll try to complete in 1 hour. If it is not feasible, I will continue the next this next part in the next week also. Okay. Now let us proceed. So, being a live session, other students may also be interested to know the contents of my lecture. Let me have a faster recap so that it will be useful to others also. But my premium students are sponsoring these classes, so you have to be very grateful, and I am also very thankful to them. And anyway, that is, let me proceed. Now, see, that is oil and water, they are not miscible. These two are immiscible liquids. In order to make it miscible, we can add soap or soap powder so that you are able to get a resultant solution that is milky in appearance. And that is why the resultant is emulsion, and the soap is the emulsifier. In an acrylic emulsion paint, that is emulsion paint, where the acrylic emulsion polymer is available. And what are the major ingredients of acrylic emulsion paint? You must have definitely this acrylic emulsion polymer. And remember, the quality of your acrylic emulsion paint depends on the quality of your ingredients and how you are going to manufacture, the process, and how you are testing. All these are very important, and what stage you have to add the respective additives. So everything is very important. Let us study one by one. Now, the major ingredients of acrylic emulsion paints are acrylic emulsion polymer, that is number one. And you should have good water. If water quality is not up to the mark, it will be detrimental to the entire quality of the acrylic emulsion paint. So you have to be very careful. You cannot take some that is a brackish water, that is a salty or saline water. Okay, that will kill the performance of the entire paint, and not only that, it will break the emulsion into 2 layers also. So you have to be very careful about this. Next, the performance, the film performance will not be as per the that is standard. Then we will be having the pigment and extenders. As we know, pigments are the true coloring agents and they have very good opacity, whereas extenders are pseudo pigments. Okay, so like a soapstone powder, china clay powder, so these things are added along with the pigments in order to fill the surface. Then you have other additives like that is anti-foaming, anti-settling, antimicrobial, etc. And there will be coalescent solvent also. So the mix of all these things are resulting emulsion paint. That's all. But as I already mentioned, you should be aware of the testing parameters of individual raw materials also, and you should know the at least some properties of certain raw materials. Now, see, that is for any paint you have to test the following parameters. These are very, very important, especially in the case of acrylic emulsion paint. That is, you should check the volume solids. It should be around 27 to 30%. Weight solids 29 to 31%. Density 1.03 to 1.08, or you can say 1.3 plus or minus 0.05 also. Then the pH should be, that is, a 8 to 9. It should be in the alkaline range. That is very important. Okay, it should be not very strong alkaline, but it should be alkaline, because at the pH around 6 to 7, the solution is susceptible to bacterial attack. So we have to make it slightly alkaline, and that is why we used to sometimes add that is aqueous ammonia also. Then viscosity, it's called the Krebs unit, that is a Krebs-Stormer viscosity is practiced. So its value should be 60 to 65, and in the case, that is Krebs unit 60 to 65, in which you should have the values 0.25 to 0.35. And similarly, in terms of poises, that is in cone and plate, that is you should have 2400. And we used to have the Brookfield spindle viscometer. So you will be having a spindle like this, and you have to dip it in the paint, and you have to allow to rotate, and the rotation can be 60 to 65 rotations per minute. In 1 minute it should revolve 60 to 65, and for which what should be the reading, it should be around 2400 to 2700. So these are all the standard parameters as far as any good acrylic emulsion paints are concerned. Now I was discussing about the that is pH, is it not? Of course, first let me explain to you about the density parameter, because this is very important. Now listen to me carefully, because density, where this density is useful, because sometimes you will sell this as liter and you will be getting the material in weight, so you have to necessarily convert the weight to liter. For example, how you can convert weight into liter, that is based on the density parameter only. For instance, let me consider what is density. Density is nothing but density, let me represent this by D. Density is equal to mass, weight by volume, is it not? And suppose if you want to have volume, what you are supposed to do, you can take the mass and divide by density, that's it. Otherwise, if you want to have mass, then and you have got only volume, means you can do volume into density. Likewise, you can interchange and get the answers. Okay, right. Now you have got density cup, it will be like this. Okay, you've got a fixed volume, say 100 ml, 50 ml, and there will be a lid. So you have to fill up the paint fully and close it. And before that, you should take the empty weight, because we have to measure the weight also. So you have got the fixed volume, that is 100 ml. So what is the weight of 100 ml paint or any solution? That is called density, is it not? So density is equal to weight by volume. So here we already know it is 100 ml, so you can put 100. So and what is the weight required? So that is the experimental value. So based on that, you can determine the specific gravity, is it not? Suppose let me say 106 is the weight of 100 ml paint, means 106 divided by 100, that is equal to 1.06 gram per ml, because we are taken in ml and the weight is a gram. So 1.06 gram per ml. Please remember this. Now in certain cases, some suppliers, they will give you in terms of kg also. So in that case, you have to be very careful. For example, if you want to convert this into kg, you know very well 1000 gram is equal to 1 kg, is it not? Similarly, 1000 ml is equal to 1 liter. So it means you can get kg per liter, is it not? Right. Now you can multiply and divide by 1000. So that 1.06 gram into 1000 means what? 1.06 kg, correct? And similarly, ml, 1000 ml means liter. So you can simply put liter. So you can convert the unit accordingly. But remember, gram per ml, kg per liter, both of them result 1.06. There is no change, because we have multiplied and divide by 1000. Do you understand this point? So whether they give it in 1.06 gram per ml or 1.06 kg per liter, the quantity will not vary. This remains constant. But in certain cases, they will give in terms of cubic meter. So you have to be very careful, because whenever you go for any tenders in the government, they would have, there are some scientific guys sitting and operating in the so-called SI units. So they will be insisting in cubic meter, something like that. So you, in that case, you should be able to give you give the specific gravity of your manufactured paint in terms of kilogram per cubic meter also. Do you understand? So that is why I am helping you. Now, here 1.06 kg per liter, that's all we have got. Now, my idea is I want to give it in cubic meter. What you are supposed to do? Now listen to me. Before that, I will teach you one important, these are all the fundamentals only, but even then you should know. See, listen, 1 cubic centimeter, sometimes it is called 1 cc, that is 1 milliliter. Done. Then 1 decimeter cube is equal to 1 liter. Okay. Then 1 cubic meter is equal to 1 kiloliter, that is equal to 10 cube liter. Kilo means 10 cube. Therefore 1 liter is equal to, otherwise you can put like this, 10 cube liter is equal to how much? 1 cubic meter. Therefore 1 liter is equal to 1 by 10 cube, then cubic meter, correct? Therefore 1 liter is equal to 10 power minus 3 cubic meter. Never forget this value. Okay, and similarly 1 decimeter cube is equal to 1 liter. These guys will be confusing you. For example, let me have this value 1.06. Okay, 1.0, because in paint the calculations are very important. You can have a empty number of formula, many references anywhere in Google, but these things are the practical guidelines I want to give you, and that's why I come here online. So 1.06 kg and then per liter. Now you can convert this into cubic decimeter also. How? 1.06 kg, and what about this? 1 liter is equal to dm, how much? Cube. So you can put like this. Okay, it means power minus 1. Therefore 1.06 kg, then dm power minus 3. Done. So there is no change in that. So till then, and we have got already 1.06 gram per ml also. Okay, and this also, it is also indicated as 1.06 gram per cubic centimeter. All are same, there is no change. But remember, because some guys, they have encountered in major problems when they ship their materials to European countries. So be careful. Now, are you able to follow this one? Let me explain once again. See, I have 1.06 kg per liter. What it did? 1 liter is equal to 10 power minus 3 cubic meter. Do you understand? Now 1.06 kg. Instead of liter, you can put 10 power minus 3 cubic meter, whole power minus 1. Done. Therefore 1.06 kg. And what about this? 10 power minus 3 of power minus 1 means plus, minus or minus plus. So 10 cube. And what about this? Power minus 3. So you can bring this here. So 1.06 into 10 cube kg into power m minus 3. Okay, it means 1060 kg. Do you understand? Meter power minus 3. So when it is given in kg per cubic meter, you have to give like this only. So don't get confused when you look at any tender. They may insist for this kind of specific gravity, but just by looking at, you will get confused. Okay, so in order to have a better understanding about this specific gravity, I am giving all the units. Is it clear? Right. Now we can have two types of measuring devices for determining the specific gravity or the density. So in this case, we use some fixed volume cup. It's called a specific gravity cup. These are available in any market, in any laboratory equipment. Now here there is a kind of pycnometer where you have got a very slim stem and you got a pear shaped bulb shaped vessel. So this is also called a specific bottle, and there will be a stopper also. So for minute calculations you can do this type of one, and for moderate quantities you can make use of this. And if you want to have, for example, you have got a lorry, okay, a big lorry is there, and you have got the tanker, okay, so it will be resting on the weighing table. Now what is the weight in terms of tons, is it not? For example, 4500 kg, this is the weight, okay, and probably that is, you may attempt to give it in a liter, okay, so they will declare the specificity is a 0.9 something, okay, so 0.85, simply taking 0.8. So what do you understand from this? That is 0.8 is the weight by volume, okay, so that is 0.8 gram per ml, that is 0.8 kg per liter, okay. So don't worry about that, you can make use of this straight away. Now what could be your volume? You know very well, the specificity is equal to weight by volume. We want to have volume, so weight divided by SG. So you can plan like volume, because you may not have the weighing facility, but you may be using some dip rod. So with the help of dip rod, you may be having some underground tank, okay, where you can, or even the above the air tank, storage tank facilities, where you have got the facility to use the dip rod. So here it will be the tank, you can put the dip rod and you can measure it by volume, okay. So for purchase people, for suppliers, for storage people, this kind of calculations will be very useful. These are all the practical thing you should know. Now I want to check the volume. So in that case, how to do that? Volume, so weight by SG. So this weight by SG means 1500 divided by, now the declared specificity is 0.8, means 0.8 you can put. Are you able to follow? Because we want it in volume. So now you can calculate, that is 4500. 4500 divided by 0.8, okay. So the value is 5625. So you should have 5625 liter. I hope now you must remember. See, the volume is 5625, but the kg is 4500. Do you understand? Now using the dip rod, you can check whether you have got the correct quantity or not, okay. So in that case, they will give you specific gravity, but don't go by specific gravity. There will be a lot of problem for you, okay. So in that case, what you are supposed to do, demand the supplier to get you bulk density. That is different, okay. So this is called bulk density. So bulk density means that what is the bulk volume, okay, and for which what is the weight, right? So for which how to calculate, you have to take the bulk density. Bulk density means what? You should have minimum 4 liter, is it not? So take a 4 liter can, you have got 4 liter, find out the weight, okay. So you can weight the, and assuming that you have got the specific gravity 0.8 means 0.8, and now you can put x. So x is equal to 0.8 into 4, it means 3.2, okay. So it may not be exactly 0.8, it may be 0.7975 like that. So you have to check in this way. So for checking the bulk density, you have to do major quantity like a 4 liter, 10 liter like that, and weigh it, so that you will get a roundabout result, and there may not be any compromise in the quantity wise, okay. Right, next. I hope this point is very clear for you, okay. Then so my student has got some doubts. I'll try to clarify his doubts at the end. Now that is I was talking about these resins also. 1 minute. Let me take up. Yes. Now this part is over. This is also over. So I will try to explain this part. I was talking about the resin because the resin quality is very important. Okay, so when I talk about this pure acrylic emulsion resin or emulsion, this is nothing but the acrylic binder. And what is acrylic? We will try to understand this one. Acrylic is nothing but, let me start some small chemistry. For example, you know CH3COO, which is acetic acid, and this is also called by IUPAC nomenclature ethanoic acid. Actually, this COOH is called carboxylic acid group. That is the main functional group. Now, this that is methyl ethyl group can be added so that you are able to get next level propanoic acid, where COOH is a functional group. The carbon atom attached immediately to the functional group is called alpha carbon atom. The next carbon atom is called beta carbon atom. So you remove one hydrogen and also here put double bond. It is called unsaturated. So CH2 double bond CH, single bond COOH. This is called acrylic acid, and its general nomenclature is alpha beta, because there is alpha beta. In between that there is an unsaturation. It means it is not satisfied with single bond. So you have got a double bond. So unsaturation means double bond or triple bond. Here you have got double bond. So alpha beta unsaturated COOH, that is carboxylic acid. Are you able to follow? And this is known as acrylic acid. This is called pure acrylic acid. Do you understand this? Now what they will do, this alpha carbon atom, where you have got this hydrogen, no? In the hydrogen they will replace with some methyl group or butyl group or propyl group. Based on that you are able to get different type of resins. Okay, this is acid, and based on that you will be getting the resins. Resin is nothing but the polymer, is it not? These are all monomer. Now you have got the methyl acrylic acid. So this is acrylic acid and this is methyl acrylic acid. Okay, methyl acrylic. So likewise you have got methyl acrylic acid and propyl acrylic acid and butyl acrylic acid. Okay, so you have got various types of acrylic acid. Sometimes butyl methyl acrylic acid, PAMA, BAMA. Likewise we used to call by some pet names also. Okay, right. So these acrylic acid monomer, they combine together to form a polymer, and that is called acrylic resin. Okay, and when it is let me talk about how it is made as a resin also. So that is another interesting part. For instance, when you take any oil, okay, now listen, oil, what is oil? In those days we used to have this many students, they ask me, sir, what is distemper? Distemper is after all made from oil bound distemper. Say it means that is based on oil, that oil is emulsified, and it is also another resin called alkyd. You should know about this also, alkyd based one. So this alkyd is nothing but, you have got some polyol. Polyol means, all means a hydroxyl group. So you will have some polyhydroxy alcohol like this. We have got some sorbitol, pentaerythritol. So likewise we have got various types of polyhydric alcohol. So you can call it polyhydric alcohol. And you have the acid also. So acid, in this case, phthalic anhydride, let us take phthalic anhydride. Phthalic means it will be having a compound like this, a benzene structure with C double bond O, C double bond O. This is called phthalic anhydride. So this phthalic anhydride, and that results polycarboxylic acid, phthalic acid. So this phthalic acid and these polyhydrol can combine together to form a alkyd. And such type of contents are available in the case of oil also. I'll try to explain that also. For example, what is oil? Oil is nothing but the triglyceride of let me explain. Oil is nothing but triglyceride of long chain fatty acid. Okay, what is oil? Oil is triglyceride. Triglyceride means, let me explain one by one. Triglyceride means, glycerol. So glycerin, these actors, they used to apply on their eyes in order to have their tears rolling down to show their sadness or weeping or crying. And this is called glycerin. So its formula is CH2OH. CH2OH. This is called glycerol. Okay, and we used to call ester. Ester is nothing but when you take, for example, something about neutralization, is it not? For instance, you have got some acid. When it combines with the base, it gives salt and water. Okay. Now this acid may be HCl. Let us take HCl, base NaOH. So it gives salt Na plus Cl. So NaCl plus water. So this is called, in inorganic chemistry, this is called neutralization reaction. Got it? Similarly, you have got a neutralization type of reaction using the alcohol. So equivalent to this base, you have got alcohol like CH3OH or C2H5OH, ethyl alcohol, etc. Plus, and you have got some acid like acetic acid, CH3COOH. You may be having here CH3, CH2OOH, ethanol. This is acetic acid. Now what happens, this ethanol and water, OH group and H can combine to give CH3, COO, CH2, CH3. Excuse me. Now this is called ethyl group. This is called acetate or generally carboxylate. So ethyl carboxylate or ethyl acetate, this is known as ester. And the process of converting the ester is called esterification. If it happens in polyhydric alcohol, polybasic acid, that is called alkyd. I hope now it is clear. So alkyd is the combination of polybasic acid and polyhydric alcohol. Do you understand? You please go through that. Let me have water and come back. Right, thank you. Now let me continue. So I hope now you are able to understand about this. See, this is polyhydric alcohol, that is triglyceride, glycerol. And long chain fatty acid means, long chain means, for example, you have got CH3. Let me take another paper. I'll talk about the carboxylic acid. The first carboxylic acid is formic acid. That is available in, it's called formica, means ant. It's extracted from ants, so that's why it's called formic acid, or by IUPAC methanoic acid. Now the next development is CH3COH, acetic acid. The next is CH3CH2COOH. So this is called 3 carbon atoms are there, propanoic acid. So likewise it goes on. The carbon chain can increase. Okay, even it will land up C17H30 COOH. In this case it's called stearic acid. So likewise it can, the carbon chain can increase like anything, and at the end you have COOH. Are you able to follow? Now this, for example, you have got lauric acid in coconut oil. and that is why coconut oil can be used as paint resin here. Okay, similarly oleic acid, resinolic acid. Okay, so oleic acid that is present in olive oil, that is why these olive oils are used in paint industries, right? Linseed oil is there, so linseed oil is also used. You name any oil that can be used in paint industry, and that is why it has got great cosmetic value and decorative value rather than its a food value. Okay, right. And so this is called, and this is long chain, and this is fatty acid. So fatty acid, is it clear? And this is available as a triglyceride in oil. So these two link like this. You can have C double bond O, O, C double bond O, O, C double bond U. Okay, long chain, long chain, long chain. This is called oil. Now in paint industry and soap industry, what they do, they break this so that you are able to get the long chain fatty acid, and you can introduce some carboxylates. Okay, so you are able to get COOK like that. Okay, now this is the polar end, and this tail is, this portion is called tail. This is non-polar. Do you understand? And this is polar. So because of this non-polar polar, now what happens? Now let me talk about the emulsion. Here you have got some greasy spot on your fabric. You cannot simply take water and remove it. That is ruled out because it is non-polar. So what we do, using this soap. Soap is nothing but sodium or potassium salt of long chain fatty acid that is derived from oil. I hope now you are able to understand. Okay, right. So nowadays we have got some synthetic resins with a long chain, and that is why we have got synthetic resins. Okay, otherwise it is called oil based resins, and they are all called oleo resinous. Okay, right. Now because using this, now this is the non-polar head, non-polar tail with head, non-polar tail with head, non-polar tail with head. So whenever you take such kind of soapy solution in any water, what happens? Surrounding takes place. Actually, let me consider a beaker, and you have got water here. When you take any salt, okay, drop any salt, that is the salt is here. Now the water molecules will be surrounding the solute, and thereby it will try to penetrate into that and disperse it. Do you understand? So this dispersion is very, very important in the case of any liquid solid interaction. And here what happens, this kind of phenomenon of surrounding of solvent molecules around the solute is called solvation. It is something like, for example, you go to some crocodile bank where when you drop any prey to the crocodiles, what will happen? These crocodiles will be crawling like this, and this is the prey. All crocodile will eaten up, and in a split second everything will go into the stomachs of this one. Finally the prey get, I think in that case it is salvation. Okay, now I am talking about solvation, means surrounding of solvent molecule. Similarly, when it happens in water, it is called hydration. Now let me come back. So in emulsion, what occurs here with the help of the soap particle? Now this is the water. So what, it will be compatible with the water. Okay, it will be compatible with the water. So you can these polar heads will be compatible with the water, and here you have the that is a greasy spot that is penetrated by this non-polar tail, and that is why this soap is called emulsifier. Okay, so it is dispersing everything, that is penetrate the greasy spot, that is oily spot. Okay, that is called the soaping action. And this kind of what do you call that is micelle, this is known as micelle. Okay, a spherical formations will taken place, and that is why you are able to get that white emulsion. I hope now it is clear. Okay, without knowing this mechanism, that is, knowing is better than simply keeping the formula, right? Now let me go into further detail. I think I was explaining about the emulsion and polymer. Okay, now whenever you take, because I already explained about the resin or the emulsion polymer, so here you have to check the appearance. First of all, it should be milky white, and you have to check essentially the non-volatile portion, that is solid content. It should be around 55 to 46. Some people they sell it at higher rate with 50 to 55, etc. Okay, so with the increase of solid content, the rate also increases, the quality also increases. That you have to remember. Now let me check. Let me tell you how to check the percentage non-volatile material. So in this case, let me consider NVM, which is nothing but W3 minus W1 divided by W2 minus W1 into 100. Let me explain this. For example, take a lid and weigh it. This is the tare weight W1. Then W2, after taking a few drops of emulsion. Now this is W2, and W2 minus W2 is the weight of the emulsion. Keep it in oven, that is maintained at 120 to 130 degrees Celsius, say about 2 to 3 hours. After 3 hours, directly you should not weigh it. Instead, you have to come here, and there is a device called desiccator. So keep it in this desiccator. Okay, and this is something like our pickle jar. So there will be a lid, huge lid. You have to slide like this. You cannot take like this. There will be a greasy portion on the lip of the container, bottom portion. Now the bottom portion will be like this, and here there will be some perforated ceramic plate where you can have on a plate anhydrous calcium chloride. So this is called desiccant. So it means it can absorb moisture. So it will absorb moisture so that you will have a dry atmosphere inside the desiccator. Okay, when you keep the that is the tested material outside the open to atmosphere, it will trap water, that will give erratic result, and that is why you have to prefer desiccator. So weigh it. Now after half an hour it will come to room temperature. Now what is the weight? W3. So W3 minus W1 will be the volatile portion will go off. The remaining is non-volatile. So this is the non-volatile or solid material. Now what is the W3 minus W1? That is difference to the weight of the solution taken is called in terms of 100%. I hope now you are able to follow this. You have to do it practically, and better is what are the equipments you require here? A small lid, oven, and a desiccator, and then that is you should have a good weighing machine. Okay, right. So solid content is very, very important. Okay, then you have to check the pH of the resin. So it should be around 8.5 to 9.5. It should be slightly in the alkaline, and you have to check the viscometer in a Brookfield viscometer using the spindle at 60 RPM, and so it should be around 1500, less than that, and it is given in terms of millipascal second. Now the film formation is very, very important. So what you can do is you can take a glass plate like this. Okay, assuming that you have got a glass plate here, so drop a few liquid, okay, and slightly tilt it. It will round down, and just check it up. This is called flow test. Okay, there should not be any bittiness, and it should form a beautiful film also. Okay, right. So this is called film formation, and this should take place, that is the minimum film formation temperature is 15 degrees centigrade. Okay, so because being a binder, you should develop a film, is it not? Right. And regarding pH, you have got the wide range 0 to 14, but our range is weakly basic. 14 is extremely alkaline, 0 is extremely acidic. So 0 to 14 is the range, complete range of pH. So if you go from left to right, that is towards 14, basic nature increases. Okay. If you come in this way towards the 0, acidic nature increases. So that is why this is extremely acidic, this is extremely basic, and this is weakly basic, and this is weakly acidic. Okay, and this is neutral. 7 is neutral. Okay. So usually the bacteria will attack in the range of 6 to 7, and that is why it should be that is slightly higher than the neutral. Okay, right. So I think I have explained about these details. Now let me come to the that is, I think I already explained about the basic formulation. Now that is how to form the film. So I have not included here the pigment, but for making a film, that should, suppose if you want to make a clear, so this formula will be helpful. Okay, a clear solution. Now emulsion polymer, it should be around a 65%. Now when you want to make it as a paint, this can be reduced. So based on the pigment binder ratio, you can, for example, when you take 25 means you can cut 25 here. Do you understand this? And apart from that, other additives are maintained properly. For example, control additive, foam control. So the foam control should be added. About this we already talked. You can refer to my previous videos also. So it should be around a 0.2%, and water should not exceed 30%, and coalescent solvent that helps you for a better flow and brushability. It should be around a 3%. It should not exceed that one, otherwise there will be a drying problem. Then rheological modifier means that is surfactant. So I will talk about the surfactant. Okay, right. So what is wetting agent? That is very, very important. So it is a very important parameter, wetting agent. So here I want to explain about the that is dispersant, because this dispersant is very, very important. Now listen to this. Right. Now, what is the role of dispersant? For instance, you have got some fine powders and you have got the resin, and this should be made as a dispersion. It is something like a tablets is ground and dispersed in honey for feeding the children. Likewise, we have the dispersion. It consists of two parts. One is dispersed phase, that is the smaller portion of the dispersion. Dispersion medium, that is the media. So this powder is a blend here and made it into uniform solution. It is not solution, it's a kind of emulsion. Okay. Now what about the powder size, particle size? Usually this is tested by residue on C, that is 3 residue analysis. You'll be having some filter, and through which how much is retained. So that is a way of studying. Now the regular pigments will be having 63 micron size, particle size, whereas micronized pigments will be having 32 micron, and we have got some 20 micron pigments also. So by reducing the particle size, the surface area increases. When the surface area increases, what happens? That will be very difficult to wet. Do you understand? So that is why we have to use an appropriate technique. Let me explain how it affects. Let me consider this is the particle size of 2 centimeter. For A is the 2 centimeter. All are equal, all sides are equal, so 2, 2, 2, 2. So what is the total surface area? You have got 6A squared, so 6 surfaces. So 6 into A squared, 2 squared means 24 square centimeter. Now I am reducing the particle size into half. So 2 centimeter is made into 1 centimeter. So how many particles you are able to get? Front 4, back 4. So totally 8. So I am able to get 8 small cubes with 1 centimeter length, breadth, width. So 6 into 1 square into 8, it means 8 into 6, 48. You just imagine, when I reduce 2 centimeter to 1 centimeter, what happens here? Surface area doubled. are able to follow? So it means finer the particle size, greater will be the surface area. Okay, so greater is the surface area means wettability will be difficult. For example, you can take a chalk piece powder and talcum powder. You can easily wet the chalk piece powder, but it is very difficult to wet the talcum powder. You can see the water droplets will be rolling around here and there. So it means because of the finer particle size, you are unable to wet it. So if it is the case with the talcum powder, then what happened to the pigment powder, which is finer than that? And I hope now you should understand the importance of wetting agent. So we have to add some surfactant. Do you understand? And these are all the rheological modifier, because if it is not properly wet, what will happen? It will settle down. That causes settling, and that is why these surfactants they can help in dispersion, they can help in anti-settling, so they can have a better rheological natures, etc. So that is why this can be broadly classified as a surfactant. Okay, right. And I want to talk about this deformer also. So whenever you formulate, deformer is very important. For instance, sometimes the deformer is added at the first stage itself, otherwise it will be detrimental for your emulsion. Then because you will be using some faster dispersion mixer, no, so that will create a lot of foams, so that will land up in hell of problems. So in order to avoid foaming, you had to use the deformer. There are different types of deformer. I already talked about that. Simply speaking, you can have broadly two types. One is silicone based, another is non-silicone based. Okay. Then at makeup stage you can add this one, and application stage it should not give any problem. For example, when you take the paint and brush on the surface, there will be some bubbles. So that will kill you the performance of the paint film. So that has to be avoided. So you have to add different type and different stages it is added. Okay, there are specific requirements for such kind of deforming action. Now based on the pigment binder ratio, you have got different type of finishes. For example, glossy finish, semi-glossy finish, satin finish, eggshell finish, and then that is matte finish, dead matte, like that. Okay, so in matte the pigment portion will be more. When I say pigment, it includes extender also. The binder portion will be less. In the case of glossy finish, binder portion is more, pigment is less. In the case of clear, there is no pigment at all. That's all about paint. Okay, and overall it requires pigment, extenders, emulsion, resin, additives, and water. And regarding water, you have to be very careful in selecting the water, because the hardness of water, that creates hell of a problem. Okay, so I wanted to there are so many trade names and what do you call different manufacturers, but I would recommend this kind of a Primal AC2337 is a very good emulsion polymer. Then I would recommend anti-foaming, that is Dow Corning 108F. Then you have got a film former IBT coalescent solvent that improves your flow, you care. And then you have got the Acrylic, this is a rheological modifier, so that you can have a better flow, and there won't be any caking formation, anti-settling is avoided. And you have got a very good biocide like Rosima. Then you have got a BioBand. These are all the polymer shielded antimicrobial agents. Okay, so you can add such kind of additives also along with your basic pigment and emulsion. Okay, now my student has got some doubts. I want to clarify those points for him. Let me explain one by one. So he has asked, sir, that is he has already asked about the interior and exterior paint emulsion difference. I already answered for him, and you can refer my previous videos for this. Then he has got one more doubt, sir, whether grinder is required for making acrylic emulsion. See, actually that is you have to use finer particle size pigments here. But when the extender portion is heavier, then you have to go for some better quality mill. And usually that is a sand mill is recommended for such kind of paint manufacturing. Some people they go for attritor also, and if the roughness of the material, in the case of a heavy primer, you can go for ball mill. So your choice of mill is based on the type of extender, type of pigment you are going to use. Okay, but normally attritor is used for generally for oil based enamels, okay, solvent based paints, and ball mills are generally used for what you call primers. Okay, and we have got some sophisticated mills. They are intended for making putty, like a pug mill. Okay, it's called pug mill. So I think I have given all these details in my regular training programs. I have shared some videos and photos also. Then this is meant for putty making, and a sand mill is for emulsion paint, etc., and even for enamel paints this is used. And some people they simply mix and give. Okay, so that is also agreeable, but they have to take superior quality mixer. So there are some mixers which have the stem, and you will not have an impeller like this. Instead you will have a disc type of impeller, where you will have a better atomizer. This is called atomizer. So the particle distribution, and there won't be any agglomeration by using a special kind of disper mix like this. Okay, this is called a homogenizer. Okay, so nowadays different types of mills are available. I will share in my telegram to my that is premium candidates. Okay, I think now that point is clear. Then he has asked one more doubt, sir, that is a water resistant purpose. There are some acrylic, specifically some copolymer and coalescent solvents used for this purpose. Then for increasing the water resistant. Then he asked about the titanium dioxide. Now let me explain about that. Titanium dioxide, it has got a two crystalline structure. Titanium dioxide, TiO2. One is called rutile, another is called anatase. So the rutile has got a better refracting index than the that is anatase, and not only that, it has got better hiding. And for water based paints, I would suggest that is this kind of anatase. Okay, and here it has the yellowing tendency. When you prefer to have exterior paint with a non-yellowing tendency, go for rutile. Okay, this is non-yellowing. And another feature is it has got better opacity, that is hiding power is better. And not only, why it is not yellowing, because it is not susceptible to UV attack. Okay, so because of its crystal nature. Okay, and this is a little bit costly, whereas this is cheaper. Nowadays further cheaper anatase materials with some extenders like Titox, Utox. So these are all very popular grades available as a replacement for anatase also. So you can have different types of and along with that you can have China clay extender, then soapstone is there. Okay, so likewise you can have a mix up of all these things and try to reduce the cost. Okay, then and only kg is enough, and liter also required. I think only kg is enough, sir, or liter is also. I have given detailed account about the kg conversion into liter. You can refer my notes in this lecture. Okay, then he has asked about, sir, what is the difference between pigment and colorant? So pigment is the it's an inert material, the true nature of pigment. Okay, pigment, let me explain about pigment and extender. Pigment, and this is extender, right? So pigment gives a true color, correct? true color, and here there is no true color, no color. It gives, just fills the surface, it acts as a filler only, that's all. Whereas pigment can hide better, so better hiding power. Extenders have low hiding power, this is better. Then pigment is inert, and extender is also expected to be inert, but sometimes this is sensitive to acid. So it may release carbon dioxide, because after they are calcite, calcium carbonate. So on reaction with acid it gives carbon dioxide. Okay. So what you have to do is, you have to be very careful about choosing the extent based on the customer requirement, where he is going to apply. So that is why we have got different types of paint, okay, based on the requirement. Then pigment, so colorant means that is a pigment that can be further classified into two. One is white pigment, another is color pigment. There are some pigments called dye-based pigment. Otherwise, you can classify this pigment once again into inorganic pigment or natural pigment, and here synthetic pigments, that is organic pigments. Okay. Apart from that, we have got some dye-based material also, but you have to be very careful about choosing once again the type of dye. But they are very sensitive to solvents and water, and sometimes it is hydrophilic or hydrophobic. Okay, but a good pigment should be inert, chemically not reactive, and that is why we used to check with the major solvents, and that is called bleeding test. For example, especially in the case of red pigment, you have to check what is bleeding. Take a boiling tube or test tube and put xylene or the powerful solvent of what you are going to use in the paint. If it is solvent based paint, if it is water, means water based, so water, you have to take water. So the relevant solvent should be taken. And this red pigment, as a powder, use some filter paper, fold it closely, tight it, and put this filter paper using a thread. You suspend for overnight, but it should be tightly packed with the Wattman filter paper, at least 44. Okay, 44 number. So you can mix it. That is, fold it as a packet and just dip it and suspend it. And you can use a jar also, okay, that is cylindrical jar, measuring jar, and close it also. Now overnight you have to keep it. Next day, if the pigments interact with the solvent, you can see, for example, if it is a red pigment, you can see the red color. It means this is called bleeding. So if your organic red color bleeds, that is not good. Okay, so it is unfit for that kind of, because it will disintegrate, deteriorate the finish of the paint. Okay, so bleeding tests should be carried out as far as organic pigments are concerned. Okay, so likewise you got various types of tests associated with the pigments, like in the case of resin. Okay, so I think let us stop with this. We will continue in the next lecture. Okay, so if there is any doubt, you can share your thoughts in the comments column. Based on that, I will proceed my subsequent lectures. Thank you very much, and thank you my students for sponsoring this online lecture. Thank you.